What else? Is that good? That's easy, yes?
Yep.
You got a couple like that on the test. So we are done with this. This is not easy. You go study, and after 10 hours of studying for this particular topic, then you come see me, okay? And it will be clear in the next 10 hours. Let's do something called valence electrons.
Valence, I like that.
Now, valence electrons are the number of electrons in the outermost shell. Did you hear that? What is it?
The electrons in the outermost shell. Outstanding.
See, I would have enjoyed you more if you would have behaved like this.
You do like.
Valence electrons, electrons in the
outermost shell.
There are various valence electrons, and then the other electrons that are not in the outermost are called inner core electrons.
Inner core electron.
Inner core electrons. So the outermost or the outer core electrons are called valence electrons. And the valence electrons is the same as the group number for representative elements. Which one the representative elements?
The S and the B.
S and P.
I forgot how to spell representative. You fill it in, okay?
You were almost there.
Yeah, almost, but then I threw a mental situation here. So,
Representative.
let's say we are in group 1. How many valence electrons for group 1?
Only got one.
Hello?
One.
1.
Wow. 1 valence electron. How many valence electrons for carbon?
It's
You need a periodic table, yes?
Four.
4.
Four.
Carbon is in group 4, so this is for carbon 4 valence electrons.
Isn't carbon in group 2?
Carbon is group 4.
No, four.
Carbon is not in group 2.
Oh, periods, groups, my bad.
Okay. So, how many valence electrons for oxygen?
Oxygen.
How many?
6.
6.
6 valence electrons. Is there a doubt about this?
No.
Is there a misunderstanding? No. You look at the group number, and that is the number of valence electrons it has. You can get it from looking at the periodic table or from the electron configuration. Like I said, for representative elements. I mean, so let's say you have this. S2P4. Where is this element? In what group is that element?
4.
6.
Okay, wait.
The oxygen,
Okay. Hold a second, Luis.
no?
6.
6.
Let's say this.
3S.
4.
I mean, the S and the P go together, right? I kind of wanted to say that, but you missed the point. So, this element is which element precisely?
Sulfur.
Sulfur.
This is in period 3, yes or no?
Yes.
And because it is in period 3, it has how many valence electrons? This is the outermost shell, yes?
Yes.
And it has, in shell number 3, it has how many electrons when you add both of these? 6. So this is a member of group 6.
Yes.
Yes.
And which is the element in group 6, period 3?
Sulfur.
Let's see. Group 1, 2, 3, 4, 5, and 6 is the group for oxygen and all its relatives.
And this is oxygen.
And this is in period 3, 1, 2, 3, that is sulfur. Okay, this element is sulfur. So from the electron configuration, I know what element it is,
Yes.
without having the rest of it. Okay? So if I don't tell you which one, the number here in the front, you can still tell me where this element belongs to. So, where is this element at?
It's
Chlorine.
chlorine.
This is in
Group 7.
2 plus 5 is
Group 7.
7. Okay, this is in group 7. Now, because I didn't give you a period, then you don't know which one it is, right? It could be any of them. Okay, and that is in group 7. That is one of the halogens. If I give you an electron configuration, how can you tell the number of valence electrons from the electron configuration? You look at the highest number, yes, and the highest number here in the electron configuration, whether it's 3, 4, or 5, and you add all of the electrons in those 5 or 6 or whatever shell you have. Yes or no?
Yeah.
All right. Which one are inner core electrons here in this configuration? Which one are inner core? These are inner core, which are 1s2, 2s2, 2p6, yes? Those are the inner core electrons. These are valence electrons, or the outermost electrons.
I'm not sure I get those.
Huh?
Why exactly are those in there for?
Because they're not in the outermost shell. Outermost shell is 3. Anything else below 3 is inner core.
So the outermost shell is always only going to contain S and P.
No, it's the highest number. Might be 3, might be 4. It doesn't matter what letters it has.
But it can't.
What matters is the number.
Could the
I'm only-
outermost be 4D, 4P?
Yeah.
It has to be 2 numbers then.
It could be even 3 numbers. But most of the time, this is only referred to as representative elements, man.
Yeah, because transition is special, that's all.
And the 3 would be the outer.
Professor,
Yeah.
in a situation like germanium, for example, which happens to have 3D10 mixed in there, you don't count those as valence because it's a part of 3?
Yes, because of the D, but
So
that will not be the highest anyway,
Right.
because that's 3D and the other ones are in the 4.
The 4S and the
And the
remaining
3S,
falls under.
and the 4S and the
That's
4P.
weird.
Okay? All right, guys. Questions about this? Half an hour, forever hold your peace.
Amen.
So we did the violations, yes? Outstanding. Valence electron configuration, blah, blah, blah. Let's go to the next chapter. First thing I am going to tell you about this new chapter, which is about the periodic table and trends and blah, blah, blah. Okay? First thing I am going to teach you are called the periodic trends. You already know effective nuclear charge. How important is effective nuclear charge? Without understanding effective nuclear charge, you'll have a problem understanding some of the rest of the stuff, okay? So, like he said, it's of extreme importance here. This is a periodic table, yes? Hello?
Yeah.
Now, there are variations. I'm going to give you the general trends, and then slowly, I am going to explain differences in the trends that are inside of the periodic table. Okay? Yes or no?
Yes.
No girl ever done it, I guess you were.
Special.
Where's your friend at? He bounced?
Oh, and the other just like.
Watching you guys. Okay, which one do you want to talk about first? Let's talk about metallic character. How about that? And you never guess what metallic character means. Which one is more metallic? Outstanding. Metallic character increases down a group and increases to this side. So which one is the most metallic element in the periodic table? I don't want you to tell me a number. It's just this one, yes? It's this one. And which one is the least metallic or the most non-metallic element in the periodic table? The one on the opposite side. How can I ask you questions like this? Well, questions like this will be, I give you lithium and cesium and potassium and ask you which one is more metallic. What do you say?
Lithium.
Hello?
Lithium.
More metallic or less?
Most metallic. Cesium is the most metallic from these three, yes? Cesium is the most metallic because it is low.
Hold on. It decreases and then increases?
No.
It
Come on,
increases
come on.
both ways.
Go on.
The back of the arrow means little. The front of the arrow means big.
Oh,
Yes,
my-
you
oh.
see it. Look.
Oh, my bad.
Look here. How big is that? Not very big.
Small.
And this, is that bigger? Yes.
Okay.
Arrow means increase. I know the book says decreases and then draw that arrow. But then the book is not. Okay, let's retry. Let's talk about
Non-metallic.
atomic radii. Atomic radii is another way for saying atomic size, yes? Here's how big the element is. Check this one out.
It's the same.
How does it look? The same. So these periodic trends, when I ask you one of them on the test, how easy is it? It's easy because once you know how to do it for one, all you have to do is memorize the rest of them, and then you apply the same thing. Yes or no? So that's atomic radii. Which one is bigger? Fluorine or carbon? Carbon is bigger because
And
it's more towards this
more
side.
to the
Yeah, more to the
Okay.
left.
That's what this says, increases this way, more towards this side. So carbon is big. Fluorine is very small. You want electronegativity now? Okay. Electronegativity. Another big deal, okay? Now, electronegativity is special because electronegativity is about in a bond which element will keep electron density towards itself. Electronegativity does not include noble gases because noble gases do not make bonds, yes? Hello?
Yes.
Electronegativity increases this way and that way. The most electronegative element in the periodic table is fluorine. The next one is ionization energy. Check that out. How does ionization energy look like? Same as the electronegativity. And what is ionization energy?
the element that has the most ions.
Energies of energy formed by bond.
Oh, actually, no.
An element
That-
is neutral, yes? Ionization means, what do you do to the element?
You're adding ions.
No, you are taking an electron from the element. So, the formula for ionization energy is an element in the gas phase loses an electron. If it loses an electron, what does it become? An ion. What type of ion? What type? This is not Ag, yes?
Yes.
Let's not do A, okay? Why don't we do this? Z? You like Z better?
Yeah.
I don't don't want you to get into your head that you're gonna get an A. So, this is going to be, if it loses an electron, what is it going to be? Ionized, and it's going to become
Plus.
positively charged. And what else? An electron. Okay? That means losing an electron's ionization energy. It's the amount of energy required for you to do what? Take the electron from an element. This here, this fluorine or this element in this area, do they have a tendency to gain or lose electrons?
They have a tendency to lose electrons.
Gain to become
They have a tendency to gain electrons. So they do not like to lose the electrons, so they have high ionization energies. These elements on this area here like to gain electrons. They do not like to lose it. That's why the high ionization energy. And that has something to do with the effective nuclear charge.
Would it
So-
also be like electronegativity? That would be like.
Yeah, but electronegativity is in a bond. But you could say that.
Okay.
Have questions? Somebody has a-
Yeah. If it becomes Z plus, doesn't it lose an electron?
No, plus.
Because doesn't gaining an electron make it Z negative?
Yeah.
Yeah.
So why did you want Z become Z positive?
because it lost an electron.
It went negative to positive.
Because the electron on the outside means that it lost that
Of
electron.
course, yeah.
Looks like you're out of
No.
It's like half for you.
If you lose money, do you have the money? No, tell me.
I get that, yeah.
I mean, if this is you and you lost money, for sure, it's not on this side, right? It's not yours anymore. If you lost it, it's gone. This is gone. This is you without money. And the money's somewhere else. This was you with the money, and then you lost it, and now somebody else has it. That's what it is. It's losing anyway. How about the other one is called Electron Affinity. An electron affinity is the ability of an element to do what? Your affinity to study for my class, is it high or small?
Hi.
Huh? High?
Supposedly high.
What a nice.
That's good.
Affinity means how much you like it, yes? How much you want it? It is gaining an electron, yes? Yes or no? It is gaining an electron. So this equation would be what? Z,
Yeah.
yes? And now what?
C
You add an electron to it. And when you add this electron to it, what do you get? You get Z minus, and that's it. Did you say opposite direction?
She wants to know what the direction is, whether it
The
goes,
direction, what's the direction?
which way does it increase?
Which way is it increasing?
Oh, you want to know the,
The same.
oh, you want to know the, okay. Of course, it's the same direction, right? What does fluorine want to do? Fluorine wants to gain an electron
To be a noble gas.
because then it won't have a noble gas configuration. But if you are a noble gas, do you want to gain another electron?
No.
No.
You're
And like I said, I am explaining to you the general trend. Next, it will be differences in these trends. Sometimes it is not that way. And I'm gonna show you those ways, and I'm gonna put them on the test, just so you can show me how much you've learned. Why are you guys looking at the watch? Is it time to go or something?
Nope.
What time is it?
15.
15 minutes left.
15 more minutes? What else is there? What else is there? You want to talk about ionic size? Ionic size is a problem. You want to talk about it now? You want to talk about the problems later? Now? No, let's talk about it later. Okay, you want it now, I give it to you now. It's not a cute periodic table, yes? Shame on you. But let's say this. Now tell me, if this is ionic size, and ionic size is the same thing as atomic size? Atomic size is the size of the atom neutral from the periodic table. Ionic size is the size of the ions after it either loses or gains electrons. Now, the ones on the right-hand side of the periodic table like to gain an electron, while the ones on the left-hand side of the periodic table like to lose an electron. The elements are going to do whatever is easier. It doesn't care about losing or gaining, it just cares about what is less of. So any element in group 3, in group 3A, what does it like to do in order to achieve the octet rule, meaning having 8 electrons in the outermost shell? You can either lose electrons or you can gain electrons, yes?
It loses.
So any element in group 3A is easier, remember, you want this number, yes? Is it easier to lose 3 electrons or gain 5? Lose 3 electrons is easier, yes? So every element in group 3 should lose 3 electrons, and if it loses 3, it's going to become a 3+ charge. Any element in group 7, what does it try to do?
Gain 1.
In order to get in 7A, in order to get to 8, what does it like to do? Gain 1 electron, and it will be -1. All elements in group 1 like to do what? Lose 1. So all elements in group 1 will have what type of charge? +1. Okay, +1. You writing it down? Group 1, +1. All elements in group 2, what do they like to do? +2, because they like to do what? Lose 2. Do they like to lose 1? No, they like to lose 2. They don't like to lose 1. In group 3, what do they like to do? Lose 3. In group 6, what do they like to do to get to 8? Gain 2. So that is a 2 minus. How about group 5? Gain 3
How about 4?
to get to 8. I'm warming you up to get to that. So, the ones in group 4, what do they like to do?
They lose or gain, depending.
They can lose 4, or they like to gain 4. They're right smack in the middle. It could be either one of them. Most of the time what they like to do is, because 4 is a lot, yes? 4 is a lot to lose or a lot to gain. What they like to do is kind of share. They say, no, I'm going to keep my 4, then you bring some, and then we'll be happy forever after. Okay? So, either one of them. Okay? So, on this side of the periodic table, what do elements try to do? Gain electrons, becoming what type of charge? Negatively charged. While these on this side like to do what? Lose electrons, become positively charged. If you gain electrons, what do you expect your size to do? If you gain pounds, what do you expect your size to be?
Obese.
Bigger or smaller?
Bigger.
And if you lose electrons, what do you become? Small. And of course, that's like weight, yes? You gain electrons, you gain pounds, you get bigger. Okay, so these elements here, which one would be bigger? One that gained 3 electrons or one that gained 2 electrons?
3.
One that gained 3 electrons. So the ones that gain 3 electrons or have a -3 charge will be larger than the ones that have -2 and the ones that have -1. So ionic charge for these here increases this way. Yes? This one is bigger. This one is bigger. Hello?
Yes.
Ionic charge. Because they are gaining pounds, yes?
Yeah.
I mean, not pounds, they're gaining electrons. So they get bigger and fatter. Outstanding. And how about these here? These are, what do they become?
Smaller.
These are skinny
Floppy.
because they are losing weight, yes?
Yeah.
And which one is smaller? the one that loses 2 pounds or the one that loses 1 pound?
2 pounds.
2 pounds. So this one is smaller than that one. Okay? So what do I say? Still going that way. That way is smaller or bigger?
Smaller.
Now let's do the arrow bigger, yes? This way is smaller or bigger?
Which way?
To the left?
Left or
No,
right?
no, you're confused. I'm confused.
Going to the left, it's getting smaller.
Smaller.
I was gonna put the arrow going to the right.
It's going bigger, so.
I was gonna put the arrow going to the right, going
No,
smaller.
to the right
Just put
smaller
smaller.
because it was 2 pounds instead of 1.
It helps to run.
To the right is smaller.
How about we put it however we wanna put it?
Okay, look, let's try to figure the other one out while we work on this situation. Now, as you go down a group, what happens to the elements? Do they get bigger or smaller?
Bigger.
Because as you go down, they have more and more electrons,
electrons.
so they get bigger, okay? So when they get bigger, even if you lose one, this one here has to be smaller than this one here. So size still.
The same as the
Really?
I want you to tell me. There's a +1 here, yes? But this one has not a +1, 1 plus. This one has one more layer of electrons than this one does, yes? So this one gets bigger as you go down.
What about that top one?
Huh? I don't know, I'm confused.
Doesn't it have to go towards, doesn't it have to go this way?
What happened?
Well, not to you, but it feels on the board.
Is there any exception with
Towards
the
the right,
D block?
towards the right.
Anything we
We're
should
not
know?
talking about the D block. So, this is bigger than that, yes?
Yes.
This is bigger than that. These elements, because they lost 2 pounds, is going to be what, bigger or smaller? Smaller. So,
That's fine, that's
is
fine.
that good?
It's the wrong way.
Is it wrong way?
Yeah, so
Yeah.
Explain to me why it's the wrong way.
because, alright, in group two, you would have to, in group two, you would have to lose 2 electrons in order to hit the rule.
Yeah, I know.
So wouldn't the arrow have to be going the other way?
Why?
It's supposed to be moving towards
You're
group
losing
4.
more, that's your.
But are you bigger if you lose 2 electrons, or are you bigger if you lose 1 electron?
If you lose 1, because then you only have to lose 1. Oh, wait. You're bigger if you have to lose 2.
You are? If you lose 2 pounds, you just get fatter, huh? If you lose 2 pounds, you get bigger.
You must be
Say
fat
I
to
weigh
begin with.
200 pounds, I want to weigh 180. And 200 pounds is pretty big, so I mean I have to lose 20 pounds to get to 180.
That's right, and when you get to 180, are you bigger or smaller than on 200?
It's not a trick question, bro.
But it has to be.
Okay, whatever, guys. Okay, here it is. An element on this side of the periodic table, without losing anything, is what size?
Smaller.
Yes.
Regular size.
Where's the atomic
What size?
radius? Look here.
smaller.
Why? This means increase.
Larger.
The elements on this side of the periodic table, are they small or big?
Yeah, more protons.
Let's say an element on this side, it's bigger, because it is. Here's the arrow. Whether it's up there or down here is the same, yes?
Wait, isn't this way going smaller? I mean, it's going bigger by period, but it's going smaller too.
No, it's going smaller that way. Because of effective nuclear charge.
Yeah, so the numbers are trying to like.
Yes, that way is getting smaller, but I'm talking about bigger.
Okay.
This way is bigger. So an element on this side of the periodic table is bigger than an element on that side, yes or no?
Yes.
Here is an element in the first group, yes or no?
Yes.
This element is big. And this element is smaller because it is to that side, yes or no?
Yes.
Correct.
And on top of that, this is losing 2 electrons. And then this is losing 1. So what do you expect this to do? This loses 1 pound. There you go. And this loses 2 pounds. So size is doing what? Increasing still this way.
Correct.
Got it.
No arguing with that.
What about the middle?
What we call the pump.
So that's not, the ionic cells are gonna be the same for some radius.
It's not the
Although,
same.
I mean, it's not the same, but follows the same pattern.
Technically,
It's a different thing, but follows the same.
It's different because this is negative and this is positive. These are bigger because they're gaining electrons and these are losing them. And if you lose them, they're always smaller than the ones that gain them, yes? So normally, if I ask you about this and this, which one is bigger?
The -3.
The -3 is bigger. But if you follow this rule, which one should be bigger?
The plus one.
Plus
This one here, yeah. That's the whole purpose of explaining the negative and the positive.
okay, so just bigger all the way across and bigger down, right?
No.
It depends on what he's asking for, if it's
I'm saying
ionic or if it's
the ones
atomic.
on the left, right? Let's say
It's not-
lithium and beryllium.
It's not bigger all across, because if I ask you for the size, you don't understand. -3 and +3 is here, yes? Yes or no?
Yes,
And this is this way, yes?
right,
But this is bigger than that.
right.
Do you understand?
Yeah.
This is bigger than that, because this is losing 3 electrons while this is gaining the 3 electrons. Yes?
Yeah.
But from within this, these are losing it. So this is bigger than this. But this is bigger than this. You not see the
Between lithium and beryllium, beryllium would be the smaller. one.
smaller?
Yeah.
What about the transition metals?
I have no idea about the transition metals. Yeah, you gotta talk to a better professor. We're not doing transition metals, okay? They're more or less the same size.